Good afternoon, students. Welcome back once again to the mathematics class. So, in the last class, we have studied definition of one-one mapping or one-one function, or you can say injective function, and many-one mapping. Already you know what is one-one mapping, or it is nothing but injective mapping also we can say. In one-one function, a mapping f from x to y is called 1 1 if element of x have a different image in y. Element of x have a different image in y. See, in the arrow diagram we can see clearly in the set A contains, it is nothing but a domain and it is codomain. Set Y contains codomain, set X contains domain, where X consists of 1, 2, 3, and set Y consists 7, 11, 15 and 19. What is 1 1 mapping is nothing but each element in set X has a different image in set Y. See, 1 has image 7, 2 has image 11, 3 has image 15. As per our definition, every element of set X has a different image in Y. Therefore, we call it as 1 1 mapping. The name itself indicates here 1 1, 1 to 1 connecting, right? It is 1 1 mapping, or you can say injective mapping also, right? Next, many one mapping. Here, again the name itself indicates here also many to 1. In previous 1 to 1, now it is many to 1, right? Many one mapping. Let's see what it says. A function f from x to y is many one if more than one element in set x has the same image in set y. Not 1 1, but it is not 1 1. Every, what we can say here, if more than one element in set x, more than one element in set x has same image in set y. The element of set x has two images in set y, right? See in the figure, set x, set y, right? Under the function f. What it shows, many one function here. Set x consists here x1, x2, x3, x4. Set y consists y1, y2, y3, y4, right? Now, many one function defines if more than one element in set x has same image in set y. See here, x1 and x3 have same image, that is y2, right? Our definition here defines a function f from x to y is many one if more than one element, it is the first element, it is second element, more than one element in set x, it is in set x, has same image in set y. y2 is the same image for x1 and x3. Got it? It is not 1 1, right? When two elements have same image from set x to y, then we can say it is many one function, or you can say many one mapping or non-injective mapping, right? Or you can say it is surjective also. Got it? Elements x1 and x3 have same image in y1. Got it? In arrow diagram we can clearly see element x1 and x3 are belongs to set x, whereas y1 is belongs to set y. Therefore element x1 and x3 have same image in y1 is nothing but many one function. Now how to check a mapping to be 1 1 or many one. How to check a mapping to be 1 1 or many one? First point, if a function is monotonic, either strictly increasing or decreasing, then the mapping is 1 1. If the function is monotonic, either it is strictly increasing. Monotonic means it is either increasing or decreasing, then the mapping is 1 1. Either f dash of x is greater than 0 for all x belongs to domain set, or f dash of x is less than 0 for all, again x belongs to domain set. Now second point, if any line parallel to x-axis, any line parallel to x-axis cuts the curve at only one point, cuts the curve only at one point, then mapping is 1 1. Otherwise it is many one. Right? There should be a curve. If there is a curve is there, let us see a second point. If any line parallel to x-axis, it is x-axis, it is y-axis, right? A curve is there. Any line parallel to x-axis, right? It is x-axis. Any line parallel to x-axis which cuts the curve at one point, which cuts the curve at this point, then the mapping is 1 1. Otherwise it is many one. If the curve cuts more than one point, then we can say it is many one. Got it? Next, onto mapping, or you can say surjective mapping. Onto mapping, or you can say surjective. In, let's see the definition. If each element in codomain, that is set y, each element in codomain, that is set y, has its pre-image in x, then mapping is onto mapping. If each element in codomain has its pre-image in x, then the mapping is onto mapping. Let's see, y consists, yes, here y consists y1, y2 and y3, whereas x consists, that is domain, x1, x2, x3, x4. Whatever definition defines here, if each element in codomain consists of here three elements, right, y1, y2 and y3, has its pre-image in set x, then that kind of a mapping we can say it is onto function or onto mapping. y1 has two images in set x, y2 has one image, that is x3, y3 has one image, that is x4, but y1 has two images here, x1 and x2. Doesn't matter, right? Our condition is each element in codomain has its pre-image, either it may be 1 or 2. There should be an image, right? It is nothing but your onto mapping. Now we move to the next, into mapping. It is non-surjective mapping. If there is at least one element in codomain set which does not have its pre-image in the domain, then that kind of a mapping is into mapping. What they are defining here, into mapping means, or non-surjective mapping, if there at least one element in codomain, that is y is a codomain, x is domain here under the function f. If there is at least one element in codomain set, in a codomain set, that is y, if there is only one element which do not have its pre-image in domain set x, then the mapping is into mapping. Let's see here. y1 has pre-image. y1 has pre-image x1 and x2. y2 has pre-image x3. y3 has pre-image x4. But y4 don't have any pre-images. Therefore, this kind of a mapping, we call it as into mapping. Got it? there should be no pre-image in domain set. Next, how to check mapping to be one or many one? One or many one in this case. Find the range of a function if it is equal to codomain. How to check mapping to be one or many one in this case? Find the range of a function. Now range means the element which are correlated from domain to codomain. Find the range of a function if it is equal to codomain. The range is equals to codomain in the sense all the elements are connected in the codomain set. Is equal means all the elements should have a relation from set x to set y. If it is equal to codomain, then the function is onto, otherwise it is into, they are telling, right? Already we have studied onto function. Onto means every element of a codomain set have a pre-image, right? That is called as into, onto set, otherwise it is into, right? Now composite function is one of the important definition in the functions. Let's see what it defines a function in the sense it is composite function. The composition of G with F denoted by GOF. Here GOF is nothing but G composition F is a function defined by G composition F of x, which is equals to G of F of x. The domain of G composition F is defined to be consist of all x in the domain of F, for which F of x is in the domain of G. That is, F composition G exists if a range of G is a subset of a domain of F. A composition can also be defined for 3 or more functions. For example, F composition G composition H of x is computed as F composition G composition of H of x, which is equals to F of G of H of x. Let's say diagrammatically or by using arrow diagram. Here first one is x under the function F of x, and again under the function G, that is nothing but the composition. X composition becomes F of x under F, and G composition which becomes under G of F of x. This second one is nothing but G of F of x, right? Similarly, in the second case also, x composition of G means it is G of x, actually it is G of x here, and F means F of G of x, it is misprinted here, right? X is a function, x is under G means G of x, it should be G of x, and G of x under F means it should be G of F of x. Got it? The composition. Next, inverse mapping. That is inverse function, in the sense the inverse function. Let's see what is inverse function here. Function f from x to y be a 1, 1 and onto function, then there exists a unique function g from y to x. Here f from x to y is there, and one more unique function we are exist here, that is g from y to x, such that f of x equals to y, which double implies g of y equals to what? X, for all small x belongs to the set x, and then g is called inverse function of f. G is called what? Inverse function of x. G is called inverse function of f, in bracket, that is inverse mapping of f. We do write it as g equals to f inverse, such that y tends to x or y to x. It may be clear from mapping diagram. It is f from x to y, and it is g from y to x, it is, right? g from y to x. Let us consider the domain of f is x1, x2, x3 and the range of f inverse which is equals to, and the range of f is y1, y2, y3 and it is domain of G inverse. Actually it is G inverse. Let us consider f from x to y, x1, x2, x3, y1, y2, y3 and in the second set g from y to x, y1, y2, y3 and x1, x2, x3. It is G inverse, right? Range of f. Domain of f equals to range of f inverse and range of f which is equals to domain of G inverse, or they taken both are f only. Here it may be clear from a mapping diagram that domain of f x1, x2, x3, here x to y, here y to x, they are considered, but both functions are under f only. If they take g then also okay, doesn't matter, both are f here. Domain of f means these elements. Domain of f is range of f inverse and range of f is, this is range of f is domain of f inverse, opposite to that, right? Inverse in the sense already you know, x which is equals to 1 by x we can say, that is reverse. Inverse process 1 by x, 1 by x, like this, x equals to 1 by x we can write, similarly we can write it as x inverse, right? Denominator directly we take in the numerator by changing its power, right? Already it is 1 is there, by taking x to the numerator it becomes x to the power minus 1, got it? Similarly here also domain of f, that is domain of f which is equals to range of f inverse and range of f which is equals to domain of f inverse, got it? Let's see next. Here in this example, if f of x equals to cos log x, then we have to show that f of x into f of y minus 1 by 2 into how f of x by y plus f of xy is the question. Then there are 4 options has been given. A is 1, B is minus 1, C is 0, D is 2, right? If f of x equals to cos log x, then they are giving this function, that is f of x into f of y minus 1 by 2 f of x by y plus f of x into y. Let us see its solution in the solution part. First let us consider, as we know, f of x is cos log x. In place of x we are taking x by y, right? Just in place of x we are replacing x by y, then it becomes cos log as it is in place of x, x by y, and again cos as it is which is equals to cos as it is. Log m by n is a property, right? Logarithm property. Log m by n can be written as log m minus log n, right? By using that property we have to write log x minus log y, and f of xy, in place of x we are taking xy, that can be written as cos log as it is in place of x, xy, again which is equals to cos of log m into n, here also log m n can be written as log m plus log n, right? Here also log xy can be written as log x plus log y. Now add this and this. First equation, second equation. That is f of xy plus f of x into y. Already we have f of xy value is cos log x minus log y plus as it is f of xy value is cos log x plus log y. Now it is in the form of what? Now it is in the form of cos a minus b and second one is cos a plus b. Already we know the formula cos a minus b and cos a plus b. Cos a minus b can be written as cos a cos b plus sin a sin b, and cos a plus b can be written as cos a cos b minus sin a sin b. By using these trigonometric identities, here one term get cancelled, that is sin term get cancelled here, positive negative, and only 2 times of cos log x cos log y remains. Therefore we can write it as 2 times of cos log x and cos log y. Here sin x, sin a sin b term get cancelled here, right? Cos a minus b is in the form of cos a minus b formula. First one. This one is cos a plus b, right? This one cos a cos b plus sin a sin b, and this one cos a cos b minus sin a sin b, plus sin a sin b minus sin a sin b get cancelled, only cos a cos b remains, that is a b in the sense here log x and log y. Therefore we get here 2 times of cos log x into cos log y. Now take 2 to the LHS here. It becomes already f of xy, x by y plus f of xy is there. Now 2 take on LHS, it becomes 1 by 2 f of x by y plus f of xy, which is equals to cos log x into cos log y. Again which is equals to, or which can be written as, already in the question cos log x means f of x. Here also cos log x is there, this much term. We can take f of x, and this term is cos log, in place of x it is y is there, therefore we are taking f of y. Therefore this term which is equals to f of x into f of y. Now substitute in the numerator f of x minus f of y as it is, minus also as it is, 1 by 2 f of x by y plus f of xy value is again f of x minus f of y. Therefore f of x, f of y minus f of x, f of y it is. Therefore the value is equals to what? 0 only. Therefore the answer is here C. Therefore here we conclude our chapter, that is relation and function, and in the next lecture series we are going to study introduction to the trigonometric functions. Till then, take care. Bye bye. Thank you.